All right. This example here is an example of how you can use z-scores in another way. So remember that with a z-score, it's a unitless scale, and so um, we can take any data that's in any other scale and convert it into a z-score. Well, what if we had two sets of data? We had two data sets, and each data set kind of had its own scale, but we converted both of them into z-scores. Could we then compare those z-scores? So that's what we're going to do here with this example. So which is a better score? A score of 76 on a quiz where the mean score was 64. So a score of 76 where the mean score was 64 with a standard deviation of 6.7, or a score of 12.5 on a quiz when the mean is 10 and the standard deviation is 1.1. So imagine you had two separate classrooms. Okay, so we have two separate classrooms. So here's classroom A, and then we've got classroom B. All right, so in classroom A, we have a score of 76. And in this classroom, the mean score was 64 and the standard deviation was 6.7. In the other class, class B, we had a quiz score of 12.5 where the class average was 10 and the standard deviation was 1.1. So two classes taught by two different teachers. Okay. And so the two different teachers, maybe this teacher had their quiz out of 100 points, and maybe this teacher had their quiz out of 15 points. And so what we're trying to figure out here, between these two different classrooms with two different grading scales, which student did better? A student with a 76 in this class, class A, or a student with a score of 12.5? Which did better relative to their classmates? So if we can calculate a z-score with class A, and we can calculate a z-score in class B, we can see which z-score is greater. The z-score that was greatest did the best relative to their own classroom. So are they going to be, so between these two, are they going to be the same? Is one going to be greater than the other? One going to be less than the other? That's what we're going to find out. Okay. So I labeled this class A and class B, but I think right up here, I put that as class 1 and class 2. Okay, same difference. So here for class 1, a student scored a 76, where the class average was 64 and the standard deviation was 6.7. And over here with class number 2, a student with a score of 12.5, where the mean was 10 and the standard deviation is 1.1. So we just want to convert these into z-scores. So let's skip this first part here. The question is, what should the answer look like? Let's go ahead and talk about that. That's an important thing to talk about. Um, so it's also very useful to try and establish maybe an expectation of where you would expect your answer to fall. And so if we if we take our mean and we add one standard deviation, we get a score of 70.7. If we take our mean and we add two standard deviations, we get a score of 77.4. So this student score of 76 is right in between those two, a little closer to two standard deviations than to one. So we're going to expect the z-score for class 1 to be close to 77. So I'm sorry, not 77, but close to 2. So close to 2, maybe just a little less. Let me do this. Okay. And for class 2, if we do one standard deviation above, we get 11.1. And if we do two standard deviations above, we get 12.2. So actually, we're going to expect our second z-score to be greater than 2. So really, without actually doing the z-score calculation, we can see that in classroom 1, it's going to be less than 2 standard deviations above the mean. And in classroom 2, the score is going to be greater than 2 standard deviations above the mean. So actually, we already know it's gonna be the student in class 2. But let's go and confirm what we're expecting here. Okay. So if x is 76, we're going to use this formula for calculating a z-score, which is what? X minus x bar all over s. And when we do that, we get a positive 1.791. So is this positive 1.791 less than 2? Yes, it is. So this answer is what we expected. How about the other one? So we're going to put in 12.5, and again, using the same formula, right? X minus x bar. And we can see that we get 2.27. That's a positive 2.27. That is greater than 2. So that's correct. So in class 2, this score, so in class 2, where the average is 10 and the standard deviation is 1.1, a score of 12.5 is a better score. And I would say then x equals 76 in class 1. Okay, so here we took two different grading scales in two different classrooms. And you would think, well, we can't directly compare them because they're two different scales. But if we convert them both into the same scale, now we can compare them. So by putting them both in a unitless scale, a z-score scale, now they can be compared. And the student's score of 12.5 is actually greater relative to their own classmates. All right, let me know if you have any questions.